Okay, so in this video, we'll be talking about production lot sizing for the main part. But there are a couple of things that I went over with the previous example that I want to finish talking about, and then we'll move on to production lot sizing. So in the last video, we looked at the EOQ example, where annual demand was 12,000, ordering cost was 4,000, price of the unit was 500, the holding cost percentage was 20%. With that, we found out that the optimal order quantity was 980. And we calculated the cycle inventory, number of orders, annual total cost, and average flow time. So a few things to keep in mind about this is the total order holding and ordering costs are relatively stable. So this is what I was talking about with robustness. And finally, one thing to remember is that if demand increases by a factor of K, the optimal lot size will increase by a factor of square root of K, because lot size is square root of 2 times demand times S, right? So everything else remaining the same, the relationship between demand and lot size is a square root representation. Now, here is an explanation for that. So if the lot size is reduced to 200 units, so annual inventory related cost will be D times Q over S plus Q times 2 over H times C will be 250,000. Because you set the optimal order quantity at a particular level, these numbers won't turn out to be the same in this case, right? But if you want them to be the same, if the question is, if my lot size is 200, how much should the ordering cost be reduced to so that my lot size becomes exactly 200? So originally our ordering cost was $4,000. So how do I figure out what the ordering cost should be? So if I go back to the equation for my economic order quantity model, which is what we have here, the equation for the economic order quantity model, this equation here. Within this equation, what I can do is I can square both sides and then solve for S. So S will be Q squared times H times C divided by 2 times D. So that will be the value of S. So it means that if I want the optimal order quantity to be a certain amount, then what should my ordering cost be? So if I can curtail my ordering cost somehow, I can move my optimal order quantity to be whatever I want it to be. In this case, I want my optimal order quantity to be 200, right? So if I want my optimal order quantity to be 200, what should my lot size, what should my ordering cost be reduced to? So I can calculate that H times C times Q square over 2D will come out to be $166.7. So this is way lower than what we are paying right now. So right now our ordering cost is 4,000. So if you want our order quantity to be 200, we have to pay way lower than that $4,000 value, right? So that's something that we can calculate. Right. So again, the relationship is K and K squared as opposed to square root of K. Right. All right. So with that, let's get to the main model that I want to talk about for this particular video, which is the production lot sizing model. So the main difference between the regular lot sizing model and the production lot sizing model is that in the regular lot sizing model, we assume that once you place an order, the order arrives all at once. So your inventory goes from 0 to Q all at once. But what if that's not the case? What if you're manufacturing the item yourself, or the order is arriving in smaller batches? So what happens then? What happens if the entire lot does not arrive at the same time? So we can call this the production. So production occurs at a specific rate. We're going to call it capital P. And inventory builds up at a rate of P minus D. Why is that? Because if P is the number of units you produce per, let's say per day, you can produce 100 items, and demand per day or averages out to be 50 items, then inventory builds up at a rate of 50, because you're making 100, you're selling 50, you'll end up with 50. So that's the rate of P minus D. So with that in mind, if you do the calculations, you'll turn out that the optimal production lot sizing quantity is square root of 2 times D times S over H times C times this factor here. This factor is 1 minus D over P. So D over P is the ratio of demand to production, and this has to be less than 1. So if your demand outstrips production, then you can never catch up. You will never be able to make enough items. You'll never hold any inventory, right? But in most of these planning cases, we'll always assume that production rate is always higher than demand. So D over P will be a number less than 1. 1 minus that will be a fraction again. That is the multiplier that you're multiplying to H times C, and that will give you the production lot sizing quantity. With that, we can calculate. So this is the annual setup cost. So in this case, instead of calling it ordering cost, we're going to call it setup cost. So there's a fixed amount of money that you have to spend to set up a machine to make production, which is a very common thing that you have to do in manufacturing. And then of course there's the annual holding cost. So if you remember, Q over 2 was the average amount of inventory that you held through the year, right? So that was the lot size. So lot size divided by 2. But in this case, the average amount of inventory that you hold per year is not just Q over 2. It's Q over 2 times 1 minus D over P. It will be less than Q over 2 because you never hold a large amount of inventory. You're making items and you're selling items at the same time. So the amount of inventory that you hold, the average amount of inventory that you hold, is multiplied by this extra factor, right? So that's the main difference. But otherwise, the formulas are very similar, right? And one last thing we'll talk about in this video is what do you do when you are lot sizing with the capacity constraint. So if the order side is constrained by K units and the optimal order quantity is greater than K, then you have to compare the cost of ordering K units and the EOQ. So you have to do like a ad hoc comparison. So what if I order Q versus what if I order capital K? Whichever has a lower cost, that's the one that you'll end up picking, right? So it's a simple comparison that you have to do in this case. Now, so this multiple orders and products in single order, this is what we'll talk about next week. So this week we talked about lot sizing with capacity constraint, production lot sizing, and the economic order quantity model. Those are the three main models that we talked about, and also the idea of cycle inventory and what that means in the larger context of supply chains, right? So that's it. So this is the last video for this week. I'll follow it up with other videos next week. But I'll see you in the next video. Take care.